Hi, this is Ben Jordan from Altium, and today I'm with iConnect 007 panel discussions. Joining me today to discuss file transfer formats for PCB design data is Hemant Shah from Cadence Design Systems, Dave Wiens from Mentor Graphics, and Karel Tavernier from Ucamco. Welcome, guys, and thanks for joining me today. It's been said that the industry needs a new file format or a new way of transferring PCB design data to fabrication for accuracy and for quick turnaround, and it's getting harder and harder with old file formats such as Gerber due to limitations in the file format or perceived limitations. And one of the issues is also data management, keeping a whole set of files together and keeping them all cohesive for getting the right product. So I'd like to start with a statement that basically the industry recognizes the need for this, but many people see that Gerber is still functioning correctly. The adoption of other standards that have come along, such as ODB++, attempt to solve some of the problems of a cohesive data set, and indeed many would argue do. But it seems we're working with file formats from the Baroque period. And if it ain't Baroque, why would you fix it?
So that's a great question, Ben. So Gerber, as you know, is proven, tested, and very reliable. It's been used since 1980s. The electronics industry has moved forward since that time. A lot of innovation has happened. And as you know, to manufacture a PC board, you need more than Gerber. Well, you need a drill file, you need a test file, you need all kinds of files that go along with Gerber. And all of that works as long as the person handing that set of files to the manufacturer makes sure all of that is aligned. Often what we find is customers make mistakes. They'll create the Gerber files or different test files or drill files and go make some change in the design, and the data set that's sent is not consistent. So this is one of the challenges that people face. So the process is broken, but people work diligently to ensure it's going to manufacture correctly, and they spend a lot of time. On the receiving end, the manufacturer has to make sure everything aligns again, because if things are not aligned, they don't want to go through a test run and find scrap, right? Because there's always going to be finger pointing. And usually for the manufacturer, the customer is right, which means the manufacturer has got to eat the cost, right? So the process on both ends is not right. We figure out how to make it work, you know? So it is broken. In this day and age, electronics industry where we can design, you know, smartphones in our small sizes, and we can, you know, have data go into the cloud and work with the satellites all the time. This thing seems like it's from the old ages. And we, as electronics industry experts, should step up and improve that process. So, and to add to that just a little bit, ODB++ was a great step forward towards that as intelligent data. Unfortunately, according to even Mentor's own survey results, only 10% of the people sort of use that. You know, so there was a problem with that, and now with ODB++ become a proprietary standard, there's a need for an open standard, an open industry standard, which is not owned by any EDA company, any software vendor.
So there's a few interesting points there, and Karel, I'd like to ask your opinion on some of these things, because from the manufacturing and CAM side of the industry, you're presenting a Gerber X2 as an alternative solution, which some of us, you know, amusingly refer to as Gerber++. But some of those issues of
it's not a bad name.
Yeah, of a non-unified data set that Hemant mentioned, and some of the issues of not receiving the drill files, the data not always being aligned, or net lists for testing. How does this proposed solution address those issues?
Okay. Well, indeed, we have CAM software, so we know what the issues on receiving data sets are very well. I'm full agreement with Hemant that Gerber is not enough. The pre-X2 Gerber, let's call it X1. It's just the image. Where I am in disagreement is that there are issues about the drill files not being present or in another format. Well, put them in Gerber. Netlist, there's nothing wrong with the 356 netlist. Of course, if you put put the wrong data in that data set, yeah, you have a problem, but you don't need a new format to fix this. You only need to put the proper data in there. This is a simple issue to solve. You don't need to throw a new format at the problem that somebody forgets a file in his archive. That's using a gun to kill a fly. But I'm totally with you that Gerber is just the image. And CAM needs more than just the image. CAM needs meta information about the image. For instance, from a path, you need to know if it's a via path or not a via path, because a via path is treated differently than a non-via path. You need to know. In X1 Gerber, there's no standard way to handle that issue. In CAM systems, this is handled by putting attributes on the objects. A via path will have an attribute saying, I'm a via path. Well, what X2 does is putting the attributes in the Gerber file, exactly the attributes that are needed, because we know which ones are needed. Before, there was no standard way to transfer this information. Now there is a standardized way in adding this information in a Gerber file. It is fully compatible with existing image transfer, which is not broken. The most advanced and complicated PCB, the image, you can transfer it in Gerber without problem. So the image side remains compatible. If somebody with Stonewall software gets an X2 file, he will still be able to read his image correctly. Nothing gained, nothing lost. X2 has always also been designed to be easy to implement. It's 5 statements, 3 pages in the spec. One supposes that if one outputs a top solder mask, it's not rocket science to add the line, this is a top solder mask. So X2 is compatible, it's very easy to implement. It's in contrast with the more complicated formats. Within reach of small players, the smaller players who dominate the market will never adopt these more complex formats. We have responses from several CAD vendors that they will implement X2. Graphicode, with the respective view, has committed to implement it by September. It's simple to do, it brings massive benefits, it solves the CAD to CAM, not fully designed to PCB, but CAD to CAM issues. The reason why the other formats have not been successful is not that there is anything wrong with ODB++ or 2581. I'm not in ODB++ or 2581 bashing. We have fine formats. But the problem is that changing image format is a complicated, lengthy, risky thing to do. Imaging software, geometric software, is very, very bug sensitive. It takes 100,000 test files until you have a reasonably reliable image transfer. What we need is to keep in place what is not broken, that's the image transfer, and add in a standard way what is broken. And that's the attributes, which are tied to the image, have to do in the Gerber format. And then you have all the other stuff, materials, colors of solder mask, etc. And there I propose to use a subset of 2581. 2581 is fine, there is no standard in place. Let's use that standard. But don't force people to adopt it wholesale. Allow them to pick those pieces that think they are useful, and it will grow. People will use more and more and more. But forcing people to change their workflow completely, and certainly change image It's too damn hard for most people.
So
and that's why it doesn't grow.
So
it's
you're proposing a two-step process of use Gerbers plus use 2581 as a two-step process to get there. Okay. And
Exactly.
your point is well taken. You can't force people to adopt a standard. People adopt a standard if they see benefits. But by the same token, I think people should have the right to go to 2581 as a wholesale one step and say, I don't want to take two-step. It's too darn slow, and I want to go the full step. And the consortium has been working with a lot of companies, supply chain companies, to validate all of that, and it's been successful so far. It's not a flip switch. It will never be a flip switch that people will just flip from one to the other. They'll do their due diligence. They'll do their due testing with their manufacturers. And that's what's been happening through the consortium.
Now, the goal of 2581 seems mainly to be not only to overcome the limitations of older file formats, but also to have a single database or a single file that contains everything needed to manufacture that board and to test it and to do the assembly,
Correct.
every single bit of data in one file, which from a data management perspective is actually ideal.
Right.
But ODB++ also solves that problem, yet the adoption is less than 20%.
Yeah, and let's not get into nitpicking on single file versus bunches of files. We know XML single file versus ODB++ is actually a batch of
Well,
files.
it's a
That's
database,
okay.
but it's
That's
a
okay.
homogeneous database.
It is a homogeneous set of data. And let's also not I'll just knock off some of the nitpicks as far as people sleeping at night because they're passing all of the assembly and test data. I mean, Hemant knows 2581, just like ODB++. We can dictate, the designer can dictate rather, what data they want to send.
They can.
Whether they want to just fabricate the board, assemble the board. Very rarely are you going to see somebody sending an entire data packet to a fab house.
Well, especially if their fab is offshore.
Right. So the data model is all-encompassing in the sense that you can output all of that if you want to, but at the same time you can choose which data you want to limit. Now, what I'd rather, and so it looks like we have 3 data formats, if not more. And it's unfortunate because designers are deliberate in their process. I won't say slow to move, they are deliberate. There is risk associated with transfer
Absolutely.
to something else.
Yeah.
And that's what we've seen. ODB++ has been out there for more than 15 years. Customers that have adopted it have been very successful with it, but the adoption rates have been slow. That, to me, is because there is an inherent risk and they're not seeing the associated reward. I can thank the 2581 effort for helping us promote that single file approach because I think we're both trying to solve the same problem in different ways to encompass all of the data to address that. It sounds like Ucamco is also trying to adopt something in a similar way. We'll see where that goes. All I can say is that there's only one today that's in production. Where these other file formats go, they can certainly come out and I wish them well. I think the industry is going to be the decision point. File format bashing really gets us nowhere. Let's let the industry decide. What I would rather frame it in terms of is an efficient design to manufacture handoff. Right. That's what we're trying to accomplish. Let's elevate it a little bit. Let's talk about lean NPI. Let's talk about the fact that we have to, as efficiently as possible, transfer data from design to manufacturing. Actually, it's a bidirectional path, because you want to get constraints into the design process, you want to get stack-ups, materials, all sorts of things in the design process. And so if you frame it as lean NPI, you look at things like doing DFM concurrently, validation during the design process to ensure efficient, who cares what data model you send if what you're sending is crap, if it hasn't been validated, right?
Garbage in, garbage out.
There you go. So concurrent DFM validation. Then complete definition of a product model to send to manufacturing. And by complete, I mean you have the ability to send as much or as little data as you want to send. And then finally, efficient process modeling. Okay, I have this data model. How do I retarget it to different manufacturing houses? How do I constrain the rules and ensure that I can manufacture as many or as few manufacturing houses as possible?
How would you respond to that? There seems to be, and I think it's actually not a very valid fear, but there is definitely a fear out there that ODB++ helps a monopoly Yeah, there's the Solutions Alliance, and there's a lot of members, including Altium, Cadence.
Ucamco.
And Ucamco. So, and the file format does work well. I mean, many CAD tools export ODB, and we find that people who use it generally get some good success with it.
Right.
But what would be your response to users out there to allay that concern?
Well, I would say, again, it goes back to trying to solve the efficiency problem. We are aligned with customers trying to solve that efficiency problem. We are all competitors at some level, managing our own business interests. And that's fine. You know, we're trying to solve problems for our customers. If we solve them successfully, then we do well. In that context, ODB++ has done well for us as a vehicle. The file format has always been, first it was managed by Valor. You could say it was, quotes, proprietary at that point.
It was still proprietary.
It was, but it wasn't a business risk to our competitors until Mentor acquired it. And so that's a business decision they have to make, that they consider it a risk, but it really wasn't up until that point.
This is really not reason for 2581 or the consortium is not because it is a business risk for Cadence. It certainly can be. It's a marketplace. It's an open marketplace. We compete on the tools and the capabilities like concurrent DFM.
I would argue that the reason a person buys a tool is not for its output.
Right. Exactly. Right. Exactly.
The reason they buy the tool is
because
it does something that they need, and it helps them solve their problems as a designer.
But the reason why people wanted 2581 to be adopted when nobody was producing, nobody was consuming, is very simple. They were afraid that their needs will not be met by a proprietary standard. Okay. It's a de facto, it's out there, people use it, but if you go beyond the large enterprises, go into small to medium-sized enterprises, ODB++ won't be found there. There'll be the myriad of file formats that they have to deal with. And smaller the company, harder it is for them. Right? So that's one part of it. And this, it's not about what the CAD tools can do with concurrent DFM. We all do that, right? It's about how does a design house hand off their design efficiently to their manufacturer. And David's right, that it's a bi-directional thing. That's right. 2581 Rev B just came out last August. It's the fastest revision to a standard in 12 months. No other standard can compete with that speed, and it was possible because the PCB design and supply chain companies got together and said, what do we need and how do we want to enhance it? And one of the things that we enhanced in 2581 Rev B was the ability to get the stack up from the manufacturer into the design house. And that's great, and surely you can do it with the proprietary standard also. The big thing is if our customers feel the need for it, then we have to serve that need. And that's what the 2581 consortium is trying to do. Meet the need of the customers, saying they need an open standard where they can influence it without any business influences getting over the format or the standard or the direction or the timing of it.
It seems regardless of which standard the industry settles on, there's a reticence to adopt. And we have two sides here. We have the fabricators and CAM people, and this is especially a concern for those who want to do high volume, low cost offshore fabrication. How can we get our business partners in other countries that are making these things to adopt whichever standard we want them to adopt? So what would you say, Karel, or each of you, what can we do as designers and as an industry as a whole to drive the adoption of what we feel is going to be the best standard?
Well, we are a small company. We do our little best in this. And this was admittedly before the IPC consortium, 2581 started, we had put out the Gerber spec there and said people can do with it what they want. We have seen that 2581 was not adopted, it was 10 years old, not a single board was produced with it. So we gave up on it at that time and said, okay, let's make something from Gerber. The first thing they did is clean out the image height spec. There was a lot of historic stuff in there. We cleaned that out. And on the top of that basis, we can build further. I think that the way forward, the practical way forward, is to, and you use what's there, and that works well, and that can do the drill files, etc. There's an automated formats, and the netlist works well in 3581. And for the things that are not covered by Gerber, use have from the beginning in the consortium put this as a way forward, not the way forward. If somebody has the courage and the money to implement it wholesale, no problem with it. But it can be done partially, and that's the only way where it will happen. This industry has stagnated with the exception of the effort of ODB, has stagnated in data formats since 20 years, since Gerber was invented, because the only solutions put forward were changed people to change their workflow wholesale. Many people are simply incapable of doing that. You get requests of improving the workflow, and that's correct, but I get every week requests from people begging me, Gerber is not going to go away, eh? No, we will continue to support it. What we now have done is the step X2, which is tied to the Gerber format, has to be done in the image. I do not propose to extend it with the materials, etc., but to combine it with the 2581. But of course, 2581 must then open it up to support partial adoption and make the links to the Gerber files possible. And I think this will happen if that's available. Because adding an XML file with materials, it's also not rocket science. It's a small step compared to adopting 2581 wholesale. I think this is a practical way we can forward. All the rest, for most industry practitioners, it's too damn hard. It's too damn hard. We've seen it. We've tried for 20 years. It hadn't happened. Try something else.
On the 2581 side, it appears that more and more US board manufacturers, the high value or value-added services are supporting 2581 and ODB++ as their preferred standards. But how do we get offshore manufacturers to adopt?
So the companies that are in the 2581 consortium are global companies. Mm-hmm. They may have headquarters in North America, but they have manufacturing plants all over the world, primarily in China. Mm-hmm. So the way consortium is working, the adoption is very simple. If there's a group of companies, the design houses that want to standardize on an efficient format that's open, they're the ones they're going to talk to their suppliers, and they're going to ask their suppliers to support it. And that's been the premise for the consortium all along. Mm-hmm. And so this is how the manufacturers that are in the consortium have come to the consortium, because they need that. Now, how to accelerate adoption? Now, Karel is right. Till 2011, in 20, 30 years, the change was zero. But for instance, 2011 to 2014, now if you just compare the math, it's exponential, mm-hmm. right? So do we go the old ways? I mean, if we did that, then horse and buggy would still be alive and automobile would not be around, right? If we always did that, right? Sure, it's old, reliable, you trust it. But at some point in time, the new kid will take over, right? So to help adoption, the other element that the consortium brings is the collaboration. Mm-hmm. We bring competitors, collaborators, design houses, manufacturing houses all together, and we meet every other week and talk about technical challenges that they face in the new designs they're coming up with. Not the old designs, the new designs, and they're trying to do new things. We look at that and figure out a way to do it. If we need to enhance the standard, we go ahead and enhance the standard. If there's a new member that comes on board and has a challenge writing the software, we provide them technical support, right? Mm-hmm. So if there are manufacturing companies that want to work with their customers, we tend to team them up with their CAD vendor supplier, the manufacturing company, and the design house together in three-way communication to get them adopted. So we are doing a lot as a consortium to help companies come on board, and we realize it's a deliberate process because handing data to manufacturing must be reliable. So we don't take it lightly. The consortium members don't take it lightly. The manufacturing companies don't take it lightly. But we enable that, we facilitate that to help the adoption. And I think this is unique. And in case of ODB++, one of the reasons why it was slow is not because it didn't have the intelligent data, but because Valor didn't put this level of effort the consortium is putting in. And there was no need for them, right?
Well, because it wasn't an industry standard or a consortium.
Correct.
It was a company.
Right.
So, Dave, what do you have to say?
And so a lot of this gets back to it's risk reward, it's awareness. It's we've had the format around. We can tout its strengths when we engage one-on-one with customers and pilot projects. We can prove its value, but it's still slow to adopt because in most cases it's a change in process. It's a risk, and therefore I have to understand the reward in doing this. And for the most part, designers, if you just talk about it as a file format thing, designers aren't going to see that reward. They have a process. It takes some X amount of time to generate their Gerbers, all the other files that are required. They know how to do that. They've done it 100 times, 1,000 times. It's repeatable. They get it done. What they're not being challenged on is time, cost, and quality. And now, in terms of quality, certainly, again, it's been proven, but there is absolutely reverse engineering or regeneration, however you want to call it, that goes on at that back end of the process. So what we try to do is show them, okay, here's a cleaner process to do. Now, I could say, because we're in a different position, because ODB++ has been around for a while, I could say 100% of design tools and CAM tools support it. 100%, I'm sure we'll find one that doesn't. Clearly my partners on this panel support it.
Yeah.
But for the most part, it's out there. So it's not a matter of getting people to say, will you accept this?
It's just a choice of
It's a choice, yeah. And so what we ask is a design house to do a very simple thing. Ask a question of your fabricator, of your assembler. What format would you prefer the data in? And if you ask them, they will tell you that they would like a cleaner format like ODB++. They will absolutely take whatever you give them, no doubt. It's a competitive market because we've asked fab houses, assemblers, look, you're telling us it costs you more, it takes more time. The NRE, they're just eating it. They're eating that because it's a competitive space. We've asked them, why don't you charge more for more difficult file formats? They can't do that. So they will absolutely accept whatever they can accept, whatever you give them. So ask them, ask your assembler, your fabricator, what format they would prefer, and see what comes back. And that's a way to drive the adoption of this. The ability to do it, to generate the files, is simple.
Okay.
I must say, I have plenty of manufacturers who helped setting up the X2 specification, because we did it with a number of manufacturers, and we put publicly a draft that for people to comment. I have plenty of manufacturers that said, I prefer to keep receiving Gerber files, because that works better, and I have as much problems with ODB
And
some cases
we're
than
talking
with other files.
Yeah.
It's not, because it's a fine format that is used in a good manner. That's
We're
the
also
issue.
dealing with training and staffing,
sure.
and there's a whole lot of labor cost involved.
Yes.
And to support new standards, we are going to need new versions of software, and so there's licensing costs. And there are, I'm sure, many good fabs stay up to date with everything, and then there are others that are slightly lower cost that takes them a while to get over to new CAM software, and so these are all things that have to be considered.
But not only that, I take a company like Eurocircuits in Europe that makes simple boards, but in big volume, 150 new designs per day. So for them, the cost of reverse engineering should be a big factor. They want Gerber X2 to happen. They prefer, clearly on their website, not to receive ODB files. And it's not because they're behind on their software. They have the latest versions. They can invest in software. They invested massively in their website and the relation to the customer, but they don't see enough benefit to change. So it's not true that all manufacturers prefer the more complete formats.
No, yeah. My statement was, I think all can accept it. Now, whether they all prefer, again, it's their business process. It's their choice. I can give you ones that also prefer 30++.
They also exist. I do not deny it.
And so,
and there is nothing wrong with, fundamentally wrong with 30++. You can do some nitpicking, but what's the point?
I think at the end of the day, we have 3 really, really good file formats that we have a choice, and it's always good to have a choice.
Yes.
So from a CAD tool vendor's point of view, and not being involved in CAM or fabrication, I can say that they all look very attractive for different reasons. Gerber X2 seems a quick and easy implementation. It just requires a little bit of effort to update both CAD and CAM software to support it. ODB++ is mature, it's well known, and it works very, very well. It's just a matter of convincing people to use it. And 2581 holds the promise of a click button solution where you can just send your data set to a fab and have a nice closed loop with the layer stacks. So they all have their strengths, and I guess we'll have to wait and see which one wins. Maybe they all will. So this has been a great panel discussion. Thanks for joining me today, guys.
Thank you for having us.
And thanks for watching.